Good morning and welcome everyone to this final semester capstone project presentation. Our proposed project is Ecolink, the mixed-use development. We are Triform Techno Design and our guiding motto is creating future-ready, eco-smart designs. Our team including
Birinder Singh Gariwal,
Danish Madan,
and Zishan Ahmed. Each of us brings unique strengths from visualization and design development to technical documentation and code research. Working together allowed us to combine these skills into a cohesive final project.
The project is located near Mattis Trail and the 88th Avenue Northeast, at the junction of Guru Nanak Gate and 87th Avenue Northeast, in the growing community of Saddle Peace Manor in Calgary. This community offers strong potential for mixed-use development as we don't have a lot of opportunities in this community for commercial activities, making it an ideal site for our proposal.
Our proposed project have a lot of amenities like park, and 100-meter away we have bus stops, and we have elementary schools at walking distance, and we have registry, we have restaurants and train station within the boundary of 1.5 kilometer.
The image highlights the key aspects of Ecolink project, a 7-story mixed-use development that blends residential and retail spaces. The design is integrated as per plan into the urban fabric with strong connections to transit and nearby amenities. Structurally, it uses a concrete podium with light wood framing, balancing durability and sustainability. Energy efficiency is achieved through enhanced insulation and glazing strategies, while full compliance with Alberta Building Codes ensures safety.
Visuals showing the comprehensive external traffic circulation plan that ensures smooth and efficient flow of traffic around the site with well-defined entry and exit points for vehicles. Our design reduces vehicular delays, minimizes congestion, improves accessibility, and enhances pedestrian safety.
Our underground parkade has been designed with safety, clarity, efficiency, and keeping in mind better vehicular flow of traffic in the basement. The circulation layout ensures smooth two-way traffic flow with optimized aisle widths, with easy maneuvering, clearly defined entry and exit routes, provide safe access, while well-organized parking stalls maximize efficiency. Accessibility has also been prioritized with direct connections to the vestibules, elevators, and stairways, ensuring a seamless experience for both residents and visitors.
These arrows highlights the vehicular movement across the site. The main building structure is supported with essential services including mullock bins for garbage collection, 2 dedicated loading stores for deliveries, and a 2-way ramp giving safe access to the underground parkade.
In the basement, staircodes are strategically placed to meet code, while aisle width exceeds 7.2 meters for safe circulation. Mechanical shafts ensures proper ventilation and prevent hazardous gases buildup, and the elevator core provides full barrier-free access across all levels.
On the commercial floor, we have 7 flexible retail units. You can see the entrance through vestibule and through lobby. We have electrical room that delivers essential building services. In these visuals, you can see the walkthrough in front of retail units, and you can visualize green spaces to enhance sustainability perspective, and can see covered mullock bin area, barrier-free stalls, and active retail frontage. These spaces are partially divided with open spans, allowing a future reconfiguration to suit a variety of tenants, and exposed structure columns emphasize the adaptability of the retail layout. Finally, the reinforced concrete stairs goes extended upward to support the structure, passing through residential floors and continue through to the mechanical level. At the roof, we have integrated solar panels lining the project with sustainable design goals.
Now we have the type 1 residential floor. These are type of A units, followed by type B units, type C units, and type D units in the building. Here is the common area and the office space provided to manage the building. The corridor spaces are designed with a maximum width of 1500 mm to ensure smooth circulation. Next is the Type 2 residential floor, which again includes Type A units with an enlarged plan shown here. Then we have the Type B units with the enlarged plans, the Type C units with its enlarged plan showing internal system, and then we have Type D units where you can also see the interior layout. The corridor here will also maintain a minimum 1500 mm width. These visual highlights the interior of the apartment, including the washroom with its aesthetic finishes. This is the shared washroom that can be accessed by visitors as well. Actually, this is a Type A unit, which is a double room layout, and you can see the modern and aesthetic interior of the kitchen, living space, and the dining area. The entrance seen in the video is connected to the corridor. And inside we have the first bedroom having storage space in it and having its own attached washroom. Another bedroom with its own connection with the balcony, and windows are provided in each room to ensure natural light and ventilation.
Here we see the front elevation featuring deep sea blue and dove grey metal panels with warm wood cladding on the balconies. Stacked stone accents frame the curtain wall, while mansard brown panels used to add contrast, and a continuous curtain wall rises from the main floor to the mechanical level. Rear elevation, Sari B's metal panels are applied, while sliding doors provide direct access to the balcony. Regal white composite panels, stacked stone, and metallic copper accents are placed around the vestibules and building entrances, enhancing the overall aesthetic appeal. Moving to the left elevations, we see diamond cut metal panels, glass railing across the balconies, and a combination of regal white panels and stacked stone. Another elevation highlights aluminium windows, brushed copper panels, and sunshades for the curtain walls. Finally, the overall 3D view presents the building in its entirety, showcasing all materials and illustrating how it will appear in the real world once construction is complete. The video concludes with a 3D visualization of the exterior cladding, bringing the design to the life.
We will be discussing details in this section. Shows the extended part of the main floor designed with a slope directing water towards the trench drain and into the main storm drain system. A thermal break balcony connector is used to minimize thermal breaching, while insulation is continuous and an air barrier is maintained on the exterior ceiling to improve energy efficiency, and glass railing is installed to ensure safety for pedestrian use, and a parapet cap has been provided to protect the structure from water infiltration and complete the aesthetic finish. This detail shows the curtain wall anchored to a slotted deflection track as a 20-inch concrete floor slab with steel-stud wood and aluminum strapping supporting the panels. A continuous air barrier and rigid insulation ensure air tightness and thermal continuity, while sloped metal flashing and the roofing membrane direct water away, protecting the structure and creating a durable, energy-efficient facade.
This detailed continuous insulation is maintained with semi-rigid insulation and an air barrier lapping over the parapet. Vertical wood and horizontal aluminum strapping supports the cladding, and the non-structural extended roof is bolted back with insulation filling the junction. Sleepers create slope for drainage, and solar panels sit on a ballasted, non-penetrating system that resists wind uplift without puncturing the waterproofing. This is the structural system for the same roof and showing the shims used to slope the roof. In this detail, the wooden roof connects with the curtain wall to ensure structural integration and envelope continuity. A parapet cap protects against water and weather, while roof truss joists tie into alveolar lumber with U-shaped hangers for strength. The air barrier runs continuously over the parapet to prevent thermal breaks, and the sloped cap directs water away, protecting the critical joints.
In this detail, the curtain wall connects to the underside of the extended concrete floor podium with sealant and membrane tie-ins to block air and water leakage. The parapet capped with metal flashing with rip edges to shed water, while rigid insulation wraps both sides of the concrete for thermal continuity. The roof truss joists tie into alveolar lumber using U-shaped face mount hangers for structural strength. In this floor-to-floor connection, the eye joists are extended outwards to improve structural stability. To address drainage at the balcony, A slope sheathing layer is added above this extension, creating a trench drain system that directs water away from the wall.
The process begins with excavation and pouring concrete for the underground level, main floor and shaft to form a strong foundation. Above the concrete base, the wooden structure rises with 2x6 lumber and metal studs, leaving proper opening for doors and windows. Joist, wall studs and roof framing are added, reinforced with plywood sheathing. Finally, the construction is completed and the building now stands in its full form.
These visuals shows the whole Ecolink project, a sustainable 7-story mixed-use development that combines residential living with retail opportunities. As you enter, the main lobby sets the tone with its open modern design that connects directly to the elevators for accessibility and smooth circulation. The amenity space provides a warm, community-focused environment where residents can relax, socialize, or work, fostering connection and a sense of belonging. Altogether, Ecolink is not just a building but a thoughtfully designed, future-ready community that prioritizes sustainability, functionality, and connected living. In this final segment, we are presenting the complete set of project drawings compiling all the work we have developed throughout the semester. These sheets bring together everything we have covered, from code compliance and bylaw information to site analysis, floor plans, sections, elevations, and construction details. As we scroll through, you can see how each page builds on the last, tracing the full design journey of the Ecolink development. The set begins with planning and regulatory frameworks, followed by site layout and building plans, and then moves into structural and envelope details that demonstrate both code and energy compliance. This drawing package represents not just the final product but the process, analyzing, designing, coordinating, and refining each step. With this, our vision for Ecolink is fully documented as a professional submission showcasing a sustainable, functional, and community-focused development. And with that, we conclude our presentation.
We would like to thank our industry advisors for their mentorship, our instructors, and the School of Construction faculty at SAIT for guiding us throughout this journey, and our families for their constant support. This project has been a key step towards our goal of becoming future professionals, and we are truly grateful. Thank you all.